Okay, now come to part 2. Okay, so for part 2, okay, we're going to talk about GIS and SMS. Total there will be 4 examples. So for GIS, okay, we got 2 examples. The first one is sodium chloride, which is NaCl, while the other one is cesium chloride. So cesium chloride, CsCl. Okay, so it is also in coming from the group 1. Okay, CaE, cesium chloride. Okay, so same as previous, you'll find that okay after we draw the structures, where you have to give a labels. Okay, what are the ions you talk about? So you see that both of them. Okay, you got the labels right there. So the first one, okay, that you're going to draw. Okay, why we put this one as part 2? Okay, actually you'll find that most of the time the structures that we are drawing is in a cube form. So to learn this one, okay, first of all, the first techniques. Okay, if you want to draw it better, okay, I'll just give you some hints. So the hints for that is okay, you have a big framework, a very big framework, okay, and then small particles. 個框要大啲, okay, and then the particle can be smaller, okay. So what means by that, you have to draw a big framework. So it will be look like this. A big framework. Okay, try to have the square, the rhombus, okay, a little bit more flat. Okay, 畫扁啲啦. So you can draw a very big structure right there. So the inner one, okay, you use dotted line to represent. Okay, look like this. So now you got a square, and then you got a cube right there. Okay, so you find that actually you can just break it down into 3 layers. So one top layer, second middle layers, and then the last one bottom layer. So each of the layers, okay, I will just use another diagram to show you. The first layer, okay, we may call it like A layer, okay, and then the B layer in the middle, okay, and then you got C layer. Okay, so if you draw like this way, you find that okay, if you try to have A, the first one, okay, will have particle like alternatively like this. You got a red one, blue one, red one, blue one, red one, blue one, red one, blue one. Okay, B, okay, it will be on the other way round. Okay, if you got a red one right there, okay, then there must have a blue one down below. Okay, so therefore we start from blue one, red one, blue one, red one, things like that. Okay, so I'll try to finish it off faster. So it will be like that. Okay, so you find that A and B, these 2 layers, okay, they are not the same. Okay, so they are just opposite. The red one get to blue, the blue one get to red. Okay, so therefore it will be look like this. Okay, and then C will just look like A. Okay, so actually more or less the same of A. So what you have, it look like this. Okay, I think the black line draw like this would be better. Okay, and then you got alternatively using red and blue to represent. So actually we'll just call this one A, B, A. Okay, A, B, A. So you find that the first layer and the first layer and the third layer, they will be the same. Okay, so let's start drawing it. Okay, so I prefer to have less line right there. It will be easier for us to recognize where are they. So let's do. Okay, do remember, okay, try to have the particles small. So therefore, the first one is a little bit big, so maybe I can just erase this one first. Give me some time. So we're going to erase this one first. This one's a little bit big for me. Okay, so first one, okay, you can start drawing a circle. Okay, in the middle, you got one. So big, small, big, small, big, small, big, small. Okay, so the first layer you'll find that okay we got 9 dot 1 2 3 4 5 6 7 8 9, so just the same as the others. Okay, so as A and the first layer and the third layer are the same, so therefore we'll just draw one more time. 1 2 3 4 5 in the middle. Okay, while the others 1 2 3 4. Okay, so you got 9 at the top layer, 9 at the bottom layer. So the middle layer will be the same, okay, but it will be on a opposite manner. Okay, but in order to help you to draw the whole things better, I think you may need some guideline right there. So therefore the guideline, okay, in the middle, okay, just like this. Okay, you just cut all the surface in the middle. Okay, and then you got to draw a line in the middle as well. Okay, so roughly you can see the you can see this pattern right there. Okay, so the blue one, 1 2 3 4 5. The red one will be 1 2 3 4. Okay, so after you draw like this way, make sure you got 9 on the top, 9 at the middle, and a line at the bottom. That would be all right. Okay, so if you want to check, you'll find that the red, blue, red, okay, blue, red, blue, red, blue, red. Okay, they will be in an alternative manner. That will be good enough. So in total, there will be 9 first layer, 9 in the middle layer, and line at the bottom layer. So this is how you're going to draw it. Okay, remember the framework. Okay, the frame, okay, the green frame, okay, have to be large, while the particles you find all these will be small. So the red one, okay, representing red one, normally the big one normally is anion. So this one is chloride ion, while the small one, okay, normally is a cation. So this one can be cation. Okay, so this one is quite complicated. Okay, while the other one, cesium chloride, will just a bit simple. So you find that this look very complicated. Okay, but actually we can simplify it. Okay, in other manner. Okay, so what you need to do is just draw a big square. Try to have it like flatter parallelogram. Flatter will be easier for you to draw. Okay, so make it flat. Again, you have the giant structures, giant framework. Okay, so this one will just make it very simple. Just all the corner, 8 of them. Okay, so this is a big circle. Again, it have to be anion, so I'll just write like this. Okay, then the small one, okay, it will be right in the center. So this one will be CS ion. Sorry, it's positive. Okay, so this is how it look like. So actually what I'm drawing is just part of the square. I ignore the other cube. I just put the green cube like this way. Okay, so you find that the one in the center of the red one actually is connected 1 2 3 4 5 6 7 8. It's now surrounded by 8 chloride ion. Okay, so this is not required, but it's just easier for you to illustrate. It's easier for you to see. You find that it is connected to 8 of the corner. Okay, so it is right in the center of the whole cube. So this part, okay, you need to learn how to draw sodium chloride and cesium chloride. Their drawing will be slightly different, okay, simply because of these two elements, cesium and also sodium, they are having different size. Okay, next we're going to talk about simple molecular structures. So as we mentioned before, the focus will be dry ice, which is CO2, and also iodine. Actually, for this one will be easier to draw compared to the sodium chloride. Again, you can see that we're going to have framework, okay? But because every time the corner, the things that appears will be a molecule, so therefore we have less alternative or alternate things, okay, happening in each layer. So again, big framework. Have a big framework. Okay, and then you got tiny molecules, tiny particles. So like this. So same as before, okay, you're going to have a ABA structure. ABA structure. Okay, but this time ABA will be slightly different. ABA. So for the first A, okay, will just exist in this corner. The corner and the center. While B, okay, will exist in a alternative manner. So it look like this. Okay, so first one for the A, okay, we're gonna draw because it's carbon dioxide, okay, we got 3 particles, so it look like this. So the first one, every corner and right in the middle. Okay, while the last layer will be the same. You got one in the middle. Okay, so for boy, second layer, okay, you got on the edge, okay, of that. So actually the edge, if it's in 3 dimension, the edge actually is right here. That means right on this surface, the center of it. So each of the surface center we got 1. Okay, each of the surface center we got 1. Okay, so this one basically you need to draw like this. I use another color, so hopefully you can see clearly. The other one. Okay, so you'll find that this one in total we got 5 molecules, 4 molecules, and 5 molecules. So it look like this. Okay, and the last one will be iodine. Okay, iodine. Okay, we draw very similar to that. Okay, but we just change the 3 atoms molecule into 2. So again, we have to draw a flat parallelogram. Okay. You find that my drawing is not that good, but still alright as long as the number of particles are the same and they're not like sticking on over each other, okay, covering each other up, then that would be good enough. Okay, so you got pair, right in the center. So you got 1, 2, 3, 4, 5. Okay, and then each of the surface, okay, we got 1. So in total there will be 4 in the layer, 5 and the bottom layer. Okay, so remember, okay, after drawing all this, okay, you have to tell me what are they. So this one is I2 molecule, while this one, the red one, okay, was talking about the CO2 molecule. So that's it. Okay, this is how we're going to draw the structure for the simple monostructures. Okay, so last page, okay, I'm going to show you all the structure that we've drawn before. Okay, so first of all, we'll have the GMS. Okay, remember we have delocalized electron and also charged particle, so you can just say cation would be good enough. Okay, and the other one, okay, will be GCS. So we got graphite. Remember the layering and also the van der Waals in between. Every one of them, they will have like 6 membrane for each layer. And then you have a diamond. Okay, this one is the most important one. Okay, remember the chicken feet diagram. Okay, and this one is silicon dioxide. I prefer you to draw something very similar to diamond. Okay, chicken feet, 3-stroke, M, V, like this. Okay, remember every junctions you put 1, and then every line you got a dot for that. Okay, so just remember every dot on each line, don't get one missing. So the dot is the oxygen atom, while the circle one, okay, it is silicon atom. Okay, just for a quick review. So all these videos we learned NaCl. So we got giant ionic structure, and you got NaCl. you got cesium chloride, you got simple minor structures, okay, you got dry ice, which is carbon dioxide, and I2. So in total, there should be 8 of them, or 8 of the structures. You have to learn how to draw it. Okay, so that's it for this video. Okay, good luck.